In this video, I have some tips and techniques for finishing off the last 4 edges on your big cubes. Okay, so the first tip in this video is for before solving the final 4 edges. When you've solved your first 8 edges using FreeSlice and you're trying to restore your centers, this is something that is, obviously very easy, but sometimes people take a little bit too much time doing this. Firstly, it's important to look ahead during this stage. So if you've got this final edge here and you just take it out, as you're doing that, you should obviously be looking ahead to restore your centers. And then the next tip that I have is to do it on 6x6. What I do is align this top slice with the second slice, and then align the bottom slice with the third slice. So I can do that kind of in 2 movements, or in 1 movement. So do that at the same time, do it simultaneously, and then after that, I align using 3 wide moves. And then on 7x7, it's a little bit difficult. It's a little bit more of a freestyle type approach. But generally, again, I'm aligning this topmost slice and this bottommost slice with the next slices. So this is going to be U prime and then D prime. And then after that, I restore it. So I guess in this situation, it was quite easy, just U2 like that. Okay, so I'm just going to go over the basic slice, flip, slice cases that you should know and use in 6x6 and 7x7. So here we have these 2 wings and this inner wing. So the 2 outer wings are solved and this inner wing is flipped. It needs to go down here. This one is here. So this is just slice like that and then flip it and then slice back. And the other slice, flip, slice case on 6x6, which is a little bit harder to recognize, is where we have these 2. So these 2 white and blues and these 2 white and blues. So the outer wings are in the same layer and the inner wings are in the same layer. So we need to do 2 slices. So slice this layer and then slice that layer, flip it, and then slice back like that. On 7x7, it can get a little bit more tricky to recognize. So here are some extra slice, flip, slice cases. So we've got this case where we've got the yellow blues. So these 3 all solved like that. And then these 2 are over here. So what we're going to do is slice this layer and then this bottom layer such that when we flip it, we flip this edge, these 2 pieces will go into this layer and this layer respectively, and we can slice back and solve the yellow and blue. Kind of the opposite of that case, and this one's a little bit trickier to recognize and it's quite rare, but when you get it, it can be really, really helpful and really quick. It's when you have this edge like so, these 2 flipped with respect to this one, and then these 2 over here. So what we do is slice this layer and this layer across to replace these 2, flip it, and then slice back. So one thing I do like to do on the 6x6 and 7x7 is solve an entire edge as my 4th last edge before moving on to anything else around the cube. I find this is advantageous because it allows me to look ahead a bit better during my final 3 edges. There's less stuff to work with and it can potentially reduce rotations as well. So let's say we're on this solve and we get to the final 4 edges and we don't see anything amazing. We don't see a single, an easy kind of slice, flip, slice solution for an entire edge. But what I do see is that if I solve this inner 3x3, this inner 1x3, using this piece, using a slice, flip, slice like that, then we're going to end up with these and this one. And this edge is over here, and it can be really easily solved with just slice, flip, slice like that. So now that one's completely solved. Obviously, if this other blue and yellow edge was over the back here or required some fancy moves or it was slightly harder, then I wouldn't have done it. I would have just moved on to solving the inner wings for the rest of the cube. But now that we've got this one out of the way, it makes look ahead a fair bit easier for these last 3. And yeah, like I said, will help potentially reduce rotations and that sort of thing. Another thing I find really nice when doing this sort of technique is setting up to the MU2 M prime cases. So here we have this case where we have these 2, this one, and this one. And what I would like to do here is just move this corner, this outer wing to this position. So I can just slice, flip, slice it like that. And now we've got this really easy situation where we can just do the M prime U2 M. to finish that off. So M prime U2M is generally faster than doing a slice flip slice. So it's really nice to just be able to set up to those cases. Again, here's just a slightly different example of setting up to one of those cases. So we've got these two. So looking at the blue and yellows again, these two and this one. And upon first inspection, this looks like a really kind of nasty case. Like you wouldn't really think of actually doing this case in a speed solve. But we can see that if we do slice, flip, slice with these inner wings, like so, then that sets up a really easy M prime U2M case to solve the entire edge. There are a couple of handy moves that you can use to flip and reposition edges during your last 4 edges, and this is something you can experiment with and see what works for you. But for example, in a case like this, we've got these two and these two back here, and if say I'm holding the cube like this and I don't want to rotate it, slice, flip, slice entirely, what I can do is just do RUR. So RUR moves this edge to the front here and takes out this edge. So RUR, slice across, and then insert the next edge like that. So that was kind of an introduction to the cycling approach for solving the last 4 edges, or solving parts of the last 4 edges on the 6x6. And this is, I guess, applying the same sort of principle that we did during the first 8 edges. So that is, whenever you solve an edge completely, you want to think about how we replace it in a manner which benefits the rest of the solve. So for example here, we've sliced to create this as our 4th last edge, and we have these two inner blue and white wings. And so if I just do RU prime R prime and slice back, then these two blue and white wings are not going to be connected together like that. Instead, we can just do an F, R prime, F prime, R, and insert there to create these two, so to match these two up like that. So cycling is something that can be done at all stages where you've sliced your centers so they're not solved, and you've created an entire edge and you need to replace it with something. I guess one thing I found recently is that even though I was doing some decent cycling, my setups and finger tricks were sometimes quite awkward to perform. So I've tried to be a bit more conscious about doing last 4 edges in a speed optimal manner, and try not to lose track of any of my last 4 edges. So in a case like this, where we've got these 3 and this one down here, the really quick and obvious solution is just do slice, flip, slice. So slice, flip, and slice back. And generally speaking, I think that's going to be the best approach for a case like this and other various cases as well. A cycling style approach would be to do something like R prime U, R prime, to take this edge out into the top, and then slice, and then insert this edge either with like L prime U L or F R prime F prime R, depending on how it would affect the others. So for example here, we've got this piece and this piece, so these green and oranges. So if we do something like a rotation and then a U2 like that, then we create these two. However, doing all those moves, so a few extra moves, an additional rotation, and obviously the moves were a bit slower, all that created was these two pieces, which in the scheme of things isn't actually that beneficial. So you do want to be kind of a bit cautious about how often you use cycling and the situations where you use it. The best way to pick this up is through experimentation and watching example solves, because there are just so many different cases that can come up. One general rule I like to use is that, let's say we're in a situation like this, if we've got these two green and oranges and this one down here, and they're a slice away, then I will do something like, take out the back edge, which is unsolved, slice, and then do cycling. So, okay, I want to insert this one like that. However, if we're in a situation like this, where we've got these two and this one, then my tendency is to just do the slice, flip, slice, rather than spend the time doing cycling and potentially impact the future stages of the last 4 edges. The other thing that it's valuable to learn are the parity cases which apply from the 5x5 onto the last 2 edges of 6x6 and 7x7. So for example here on this 6x6 case, we've got a situation where we've got these two and this one. So this one's flipped, this inner wing, and its other inner wing is here. And then we've got the same reverse scenario over here. So we've got these two outer wings solved, and this one is flipped. And to solve this, we apply the parity algorithm on the 5x5, we just use inner slices. So this situation, R prime U2, R2 U2, R U2 prime, R prime U2, R U2 prime, R2 prime, U2 prime, R prime, like that. We just do the same thing on the 6x6 using slice moves. So like that. This sort of thing can also be applied using inner slice moves on the 7x7, and it's very important to keep in mind that this is just one example of applying last two edges algorithms on the 6x6 and 7x7. There are various other cases which you can apply these algorithms to as well. So this is just, one specific example. So you should experiment with all the others. But on the 7x7, this is quite a rare case, I guess. What we're going to be doing is essentially the same algorithm that we did before on the 6x6. However, it's a bit more obvious to see what we're doing on the 7x7 here because we're using inner slices, so this layer, we can see that these two pieces won't move and these two pieces won't move. And so it's effectively just solving these inner pieces. So solving them like that.